Hello friends, today we are going to start with laws of motion. We are going to cover three topics today. Motion of an object, distance and displacement, and finally speed and velocity. So let's start with motion of an object. In the book there are four examples which are given to differentiate between the presence and absence of motion. First is the flight of a bird. The bird is flying in the air, so presence of motion. A stationary train, the train is at rest, so absence of motion. Leaves flying through air, presence of motion. A stone laying on a hill, absence of motion. Sometimes we are not able to feel the motion of an object. For example, a gentle breeze or a wind. We can feel it. We know the wind is blowing. Can we give some more examples? For example, yes, of course. For example, a person walking on a street, a rider cycling on a bicycle, a plane flying in air, a helicopter flying in air. These are all examples of presence of motion. Now, there is a situation which I am going to give you. For example, you are in a bus. There is a person sitting next to you. So, is that person which is sitting next to you is in motion? No, the person sitting next to me is not in motion with respect to me. He is at rest. But if I get outside the bus and become an observer, then that person is in motion for me. The bus is moving and so is that person. So we can say that motion is a relative concept. Now let's come to the second topic, distance and displacement. Suppose this is point A and this is point B. Now I travel from A to B through this path. I take another path. I take this path and travel from A to B. Then I take a straight line path from A to B. Which one do you think is the actual path? Actual distance between A to B. The shortest distance between A to B is a straight line, which you can say as the shortest path or the correct path. Because see, I can travel from A to B in a number of paths. I can take this path, I can take this path, but the actual distance is 10 meter, which is a straight line distance between A to B. This straight line distance between starting point A and finishing point B is called displacement. And these are all the actual distances covered from A to B, say 1, 2, 3, 4. These are all the distances covered between A to B. So let's understand the concept of displacement by two more examples. Suppose this is a circle and this is a point A. Swirly starts from point A, covers this circle along the perimeter and reaches back to point A. So what is the distance covered by swirly? The radius is r. We know that the perimeter of a circle is defined as 2 pi r. So the distance covered by swirly is 2 pi r. And what is the time taken? T. Suppose the time taken is t. So what is speed? Speed is 2 pi r upon t, distance travelled upon time taken. But what is displacement? Displacement is the shortest distance between the starting and finishing point, which is A. So displacement is 0. She started from A and came back to A. Displacement is 0 and distance travelled is 2 pi r. Let's take another example and try to understand it further. Suppose this is point P and this is point Q. The distance between point P and point Q is 360 meters. A car starts from P, goes to Q and comes back to P. So what is the distance travelled by car? (360 plus 360 meters, which is equal to 720 meters. But what is the displacement? Displacement is the shortest distance between the starting and finishing point. It started from P and came back to P. So displacement is 0. Now let's come to our third topic, speed and velocity. Speed. We know speed is total distance travelled upon time taken. But what is velocity? Velocity is defined as distance travelled in one direction by an object in unit time. The shortest distance travelled in one direction in unit time, which is nothing but displacement upon time. What is the SI unit of speed and velocity? Meter per second, which is International System of Units. What is CGS system? What is CS unit? Centimeter per second. See, distance travelled is also measured in meters and displacement is also measured in meters. So both have same units, meter per second, and in CGS, centimeter per second. CGS unit, CGS system is used in some specialized branches of physics, whereas globally we accept SI units. So if I say an object moves from point P to point Q with a speed of 40 meter per second, then I am saying the velocity is 40 meter per second in east. When I give a direction along with the speed, that means I am defining velocity. I am saying 40 meter per second east or north or south. I am giving a direction along with the speed. So I am giving velocity. Now the object has traveled between P to Q in a straight line. So speed is also same 40 meter per second and velocity is also same 40 meter per second. But when I am defining velocity, I am saying 40 meter per second east. I am giving direction along with it. What are scalar and vector quantities? Scalar quantities have only magnitude. We have studied this in earlier class. Like speed, say the object is moving at 10 meter per second speed. We are not defining direction along with it. Time, we say 12 o'clock, we say 2 hours. We don't define direction along with time. Distance. So speed and distance are scalar quantities. What are vector quantities? They have both magnitude and direction. When we say an object moved from point P, starting point, to point Q, which is the finishing point, we are defining a direction, P to Q. So this is displacement, which is a straight line. So displacement is a vector quantity. When I am saying object moved from P to Q through this path, or it covered this path, then I am not defining a direction. That is distance. So displacement is a vector quantity. Velocity is derived from displacement. We know velocity is displacement in unit time. So velocity is also a vector quantity. So velocity and displacement are vector quantities, whereas speed, time and distance are scalar quantities. Now let's understand speed and velocity more clearly through another example. Suppose Pramila and Prashant in a house A. This is B where Sangeeta stays. And C is school. Now suppose Pramila covers a distance of 500 meter and reaches to B, that is Sangeeta's house. Then she covers a distance of 1200 meter and reaches to school. What is AC? If we recollect, we have studied in Pythagoras theorem that for a right angle triangle, the length of the hypotenuse is the square root of root over 500 square plus 1200 square. So this is 1300 meter. So Pramila travelled a distance of 500 meter and then 1200 meter to reach school, whereas Prashant reached to point C, that is school, by covering a distance of 1300 meter. So Pramila took and if they both traveled with the same speed, I am saying the condition is that they should be traveling with the same speed. Then Prashant of course is going to take less time to cover the distance of A to C, whereas Pramila is going to take more time to cover a distance of 1700 meter. Now for example, let's say Pramila moved to Sangeeta's house in 5 minutes. And from Sangeeta's house to school, she took 24 minutes. So what is the speed of Pramila from A to B? Pramila is traveling at a distance of 500 meter. She is taking 5 minutes. So the speed is 100 meter per minute. What is the speed between from B to C? It is 1200 divided by 24 minutes, which is 50 meter per minute. But what is the average speed of Pramila? Total distance travelled is 500 plus 1200 and divided by total time taken, which is 5 plus 24. So this comes out to be 1700 upon 29, which is 58.6 meter per minute. This is the average speed taken by Pramila. We don't average it out like 100 plus 50 divided by 2. Average speed will be total distance travelled, which is 500 plus 1200 divided by 5 plus 24, which is total time taken. We don't average out through the other formula like 100 plus 50 by 2 because the denominators are different. Time taken is different from travelling from A to B and B to C. Now this was average speed, but what is velocity? Velocity is defined as displacement upon time. So what is the displacement? Pramila travelled from A to B and B to C, but displacement is 1300 meter, that is AC. And time taken is 29 minutes. So AC is 1300 divided by 29, which is 44.83 meter per minute. So speed is 58.6 meter per minute, but velocity is 44.83 meter per minute. So speed is different because she travelled a distance of AB and BC, and velocity is different because the displacement is AC. Actual distance travelled is only 1300 meter. So we are going to continue with speed and velocity, and further we are going to talk about acceleration in our next class. Till then, bye. See you.